So, in theorem 6 or section 6-5, we are given these three theorems. These three theorems are just converses of previous theorems. Okay, so 6:16 is the converse of 6:13, 6:17 is the converse of 6:14, and 6:18 is the converse of 6:15. This first example is a proof. I'll tell you right now, anytime we work proofs in this class from here on out, it's going to be together as a class. I'm not going to test you on a proof or anything like that. Maybe I'll put a proof on a test as a bonus point or something, but it's never going to be a part of your test. We'll do those together. But what are the things I want you to know or be able to do from this section? Well, go to the back side of your notes. All the problems on the back side of your notes, I expect you to be able to do. So, looking at example A. In example A, they're asking us, or they're telling us that we have a parallelogram. That's in the instructions. So we know this is a parallelogram, and we want to know, is this parallelogram a rectangle? Is it a rhombus? Or is it a square? We want to be as specific as possible. So looking at this parallelogram, what is a key feature they're showing us here? The diagonal. What about the diagonal? It's an angle bisector. The diagonal is an angle bisector. So therefore, this shape must be a what? Rhombus. It's a rhombus because the diagonal is an angle bisector. Or you could simply said theorem 6 dash, off the top of my head I can't think of which one that was, 6-17? Yes. Okay. I mean, that's all I need you to do. Okay? You need to be able to justify why it's a rhombus. You need to tell me what theorem it is. And again, as always, folks, if you don't remember the actual theorem number, then tell me what the heck the theorem says. Okay? All right. Let's take a look at example B. In example B, given this diagram, again, we know that we have a parallelogram because they tell us that. We want to know, is this a rectangle, a rhombus, or a square? So, looking at what they give us, what do you think? Okay, you're thinking square. Now, why a square? Say that again? Oh, yep, you're looking right here saying that we have a 90-degree angle. So that means that this diagonal is perpendicular to that diagonal. I agree with that. Well, that's a feature of what? A rhombus. Okay. So we know that this is a rhombus, and that is because the diagonals are perpendicular, which is theorem 6-16. Okay, I agree, but we're not done. That's not the only thing they give us here. They also tell us that all those little 4 segments in our rhombus are congruent. Okay, well, what does that mean here? If this segment here is congruent to this segment, and congruent to this segment, and congruent to this segment, what is that telling us about these entire diagonals? The diagonals are congruent? Yeah. What's that a feature of? Rectangles. A rectangle has congruent diagonals. And that was theorem 6-18? I believe so.
Yeah.
Excellent. Okay, so we know it's a rectangle. So wait a minute. How can it be both a rhombus and a rectangle? So it's a what?
Square.
It's a square. You were right to begin with. We just got to explain why. Okay? If it's both a rhombus and a rectangle, if you look at your flow chart, remember, looking at your flow chart, it comes down from a parallelogram, and it says, okay, over here are rectangles, over here are rhombuses, but then square is down here. And square comes from both a rectangle and a rhombus. Okay, so if it is both of these, that means it must be a square. Okay? And it's a square, and I want to do a reason for that. I would say because of the definition. Okay? If you look back to the definition of a square, it says that it has 4 right angles. That means it's a rectangle. And it has 4 congruent sides. That means it's a rhombus. Okay? So if a quadrilateral is both a rhombus and a rectangle, that makes it a square. And we were able to show that. All right, questions on this example B? Let's take a look at our first example down here. These, again, are the types of problems I'm expecting you to know how to do from this section. We've already done ones like this. We've already dealt with all the theorems we need to work with on these. First things first, they're telling us information. They're saying, for what value of x is, what the heck is that? That's a parallelogram ABCD. So they're telling us that we have a parallelogram. We need that information. And we want to know for what value of x is it a rhombus. Okay. Well, looking at the diagram, what do we call this segment? Well, we don't know that yet. We know that it's a diagonal, right? Absolutely. We know that it's a diagonal. And again, I'm just trying to spell it out for you guys here, making sure you know what you're supposed to be looking for. 6x minus 2, what is that referring to? What's that arrow pointing to? An angle. 4x plus 8, what's that pointing to? An angle. Now, in order to be a rhombus, what has to be true about this diagonal? It has to be an angle bisector. Okay? Remember that we're kind of doing the converse now. We're proving that we have a rhombus. Okay? And so in order for it to be a rhombus, we have to have an angle bisector. So I would say then 6x minus 2 equals 4x plus 8. I need you guys to slow down and look at that. I'm going to show you something right now that is a mistake I'm seeing people make on those quizzes. Okay? I'm seeing people go through here and say, all right, I want to go ahead and combine some like terms. So I get 10x, and I'm going to combine those guys, so I get 6. And I'm going to put my equal sign between the two, so x must equal 6/10 or 3/5. Okay? You can't do that. There are so many things wrong with what just happened. All right? Let's get that off the screen. Again, the equal sign is a fixed point. It cannot change. It is an equal sign. All right? We use our rules of algebra. Again, everything I'm saying right now, I know that you know. But I want to spell it out because people are rushing and making mistakes on things that you shouldn't be making mistakes on. If I want to solve for x, I need to get my x's onto the same side. So I'm going to collect all my x's over to the left. I'm going to subtract my 4x here. Why am I subtracting? Because it's a positive 4x and I want to get rid of it. If I subtract 4x from one side, I have to subtract 4x from the other side. So I get 2x. I still have a minus 2, and it's still equal to what's left over on the right side, which is a positive 8. Now, to get my numbers over to the right, I have to do the opposite operation here, which means I'm adding 2 because it was a negative 2 to start with. 2x equals 10. And now I am dividing both sides by 2, and so x equals 5. Okay? I know you know how to do that, but we've got to slow down to make sure that we're working those problems properly, because I'm seeing people make mistakes. You're rushing. Okay? And so the answer to this question is x equals 5. When x equals 5, that shape is a rhombus. Okay? What if x was 6? It's not a rhombus. What if x is 4.9? It's not a rhombus. The shape is only a rhombus if x equals 5. Questions on our first example here? No. Okay. Let's look at the next one. There's a little bit more involved in this one. You got to make sure you really look at what's going on. So flip back, take a look here. I'll leave this up on the screen. I want you guys to look at your flow charts on the back side of your notes. Okay? We have a parallelogram, because they tell us it's a parallelogram. Okay? What is drawn in our parallelogram? What's the extra pieces here that's drawn? The diagonals. The diagonals are drawn. Great. What do we know about the diagonals in a parallelogram? In a parallelogram, they bisect each other. So because we have a parallelogram, we positively 100% know that this segment and this segment are congruent. This segment and this segment are congruent. Right? We are guaranteed that because it's a parallelogram. Okay. But we want to show that it's a rectangle. So we want to find a value of x, or in this case a value of y, that makes that a rectangle. Well, now, what has to be true about the diagonals to be a rectangle? The diagonals have to be congruent. So, if the diagonals are congruent, meaning they're the same length, and they're being bisected because it's a parallelogram, that would mean that all 4 of those smaller segments would have to be the same length. Correct? That would show that the diagonals are the same length and that they're being bisected. Everybody agree with that? See where I got that? Okay. And therefore, because we're not given the entire lengths here, we're only given this length of that segment. We're only given the length of this segment. Okay? That means, in order for this to be a rectangle, those 2 segments have to be congruent. I wanted to make sure to spell that out because you can't simply say, well, those 2 things have to be the same length unless you know why. Because the theorem doesn't say that part of the diagonals have to be the same length. The theorem says the entire diagonal has to be the same length. Right? And so we had to know, well, why are we able to only work with parts of them? We're able to work with parts of them because this is a parallelogram, and in parallelograms, the diagonals are bisected. Okay? They're bisecting each other. And so because of that, and because we want the segments to be the same length, we can then set up this equation. So, quickly solve this. I want to see your answer. Ready, set, go. All right, excellent. So everybody got there? We know that y equals 4. Excellent. So when y equals 4, we have a rectangle. Okay? There's only one last problem I want to do, and actually I'm not even going to work the whole problem out. We're just going to set it up. We can write down here, what value of x makes this shape a rhombus? Well, what feature of a rhombus are we supposed to be trying to use here? What about the sides? But congruent sides, yep. Because opposite sides being parallel, yeah, that's true in a rhombus, but that's a feature of parallelograms, right? Not specifically of a rhombus. But in a rhombus, all 4 sides have to be congruent. And therefore, we need to find the value of x that makes that happen. So we set up 8x minus 1 equals 3x plus 9, and then, of course, solve for x. Okay? Questions?